Hey guys, and welcome to our last lesson for this unit on basic geometry. Now again, we're going to talk about using the formulas for distance, midpoint, and slope, but we're really just going to focus on slope today. But we do have a new SOL in this lesson, which is applying slope to verify and determine whether lines are parallel or perpendicular. This is probably so far the most important lesson of the school year. The last one with the formulas for distance, midpoint, slope are extremely important. But this one, they love to ask questions like this on the SOL. So that's why we need to focus on this, and that's why I made it as its own separate video. So first off, we need to do a little bit of an Algebra 1 review, just for a couple problems. Find the y-intercept. To find the y-intercept of an equation, I plug 0 in for x and solve the resulting equation for y. So a lot of this is going to be an algebra review, but I just want to make sure we know how to do this. So our first step, we said, is plug 0 in for x. So 6 times 0 plus 3y equals 12. That's the very first step. Now the beauty part about plugging 0 in for x is anything times 0 is just going to be that 0. So that goes away, and I'm left with 3y equals 12. First secret phrase, Eddie Mush. Eddie Mush. Now we said we want to solve the equation for y, so all I have to do is divide both sides by 3, so I get that y equals a 4. So that's going to be my y-intercept, is 4. And that's all I have to do for that to be able to figure out what the y-intercept is. Now I noticed on my last video that I was chewing my gum real bad. Unfortunately, I forgot to spit my gum out this time, but I promise I won't chew it as bad as the last time, for those of you that it may have annoyed. So I do apologize for that. In fact, not even going to be an issue. So this is our first example. Plug 0 in for x, solve it for y. We may need to do that later on down the road, so I want you to see it. Here's your practice problem, so just follow along, do the same exact thing that I did, something we did probably multiple times last year in Algebra 1. Second example, converting from standard form to slope-intercept form. Now this we do need to know how to work with. Standard form is ax plus by equals c, and slope-intercept form is y equals mx plus b. This is where I always want to get. I always want to try to get the y by itself because this tells me my slope. I can't find my slope over here. So the way we do that is we have to solve the equation for y. This is done by adding or subtracting the x term, then dividing by y by the y coefficient. It must be done in order to determine the slope of the line. And that's what's important for this lesson, is I need to be able to find the slopes of lines. So I had a teacher friend of mine used to say, put a box around the variable you're solving for. So that way I know not to move that one. So we said before, we need to add or subtract the x term. So if this is here, it's a positive 6x, I need to subtract it from both sides. This goes away, I'm left with a plain old 3y equals, and this is where some of us might mess up. These are not like terms, so I can't combine them. Okay, I cannot put them together. So I'm going to have to say negative 6x plus 12. That's as combined as I can get. That's the closest I can get, because this doesn't have an x, and this 6 isn't by itself, so I can't put those together into one term. Now I put the x term first because of y equals mx plus b. It really doesn't matter if you want to say 12 minus 6x, you're still saying the same exact thing. But this is the way math nerds like me like to write this. Now again, we want to put a box around the y, and I even gave you a clue that says we need to divide by the y coefficient. Or if there's a fraction, we would multiply, but this time I have a whole number. Now when I divide, I need to divide every single thing by that 3. Okay? So these 3's cancel out, and I'm left with the plain old y, which is what I want for slope-intercept form. Negative 6 divided by 3 is a negative 2x, and 12 divided by 3 is a 4. So this is my equation. This is the same exact line as this guy in slope-intercept form, where the slope is negative 2, or negative 2 over 1, which we'll talk about here in a few minutes, and the y-intercept is 4. Okay? Now if you notice, I believe this is the same exact equation as the first one that I did. And we said that the y-intercept was 4, and that's exactly what we said here. The y-intercept turned out to be 4 as well. Okay? So when I do that, whether I solve it for y or whether I plug the x in or plug 0 in for x, I should still get the same exact y-intercept. Here's another practice problem for you folks. Here are your steps again. If you need to, please feel free to rewind, watch what we just did together, and go ahead and do this one on your own. If you have any troubles or confusion, please remember to put a star next to a problem so you know to ask in class next time. Now here's our next example. Point slope form. This one we at least want you to know for in case something crazy happens, but it's really not that great of a problem. It can be a little bit tricky, so let's just go through it. It's used to find the equation of a line when I'm given the slope of a line and a point on the line. That's why it's called point slope form. It can also be used when given 2 points, since we can use the slope formula to calculate the slope and either point to find the equation of a line. I'm going to put a star by that because you might need to use it later on. So this time I'm given a point, which is -1, 4, and I'm given the slope is 3. So point slope form is y minus y1 equals slope times x minus x1. And that's an x, not a y. Now with point slope form, the plain old y and the plain old x stay there because I eventually want it to look like this. I eventually want to put it into y equals mx plus b. So I need a plain old y and a plain old x, and I need that left alone. My slope is 3, so I'm going to go ahead and plug that in there, and we'll have the plain old x and the plain old y as we said. This point is x1, and that's y1. So y minus y1, which is 4, equals the slope times x minus x1. And this is where I need a double negative. Second secret phrase, Tony to pay. Tony to pay. Now I do need to use the double negative because I have the negative sign here for the equation, or the formula, and I have the -1 from the point. So I want to clean this up a little bit before I do any real algebra and see that that minus a -1 is the same thing as saying plus 1. Okay, x minus a -1 is the same thing as saying x plus 1. Now I need to get rid of these parentheses. And let's think back to Algebra 1. How do I get rid of parentheses in an equation? I distribute. Now, even though I've been doing math for about 175 years, I still like to draw my arrows. And I highly suggest you do the same thing, because I need to remember to distribute the 3 to both things inside. Now I'm going to leave this y minus 4 alone. 3 times x is 3x, and 3 times 1 is a positive 3. Now some people may want to say to stop, but I would want to get the y by itself, because as I told you, we want to try to get this in a y equals mx plus b. We want to make that look like this. This is how we always want to end up our problems, because this gives us the most information. So, the way I get the y by itself is because this is a -4. I need to add 4 to both sides. Remember, I always do the opposite. Now, I'm not adding 4 to every single thing like when I divided earlier. I just need to add it to my like term, because 3x plus 4 doesn't give me anything. Those aren't like terms. But 3 plus 4 will give me a 7. And that's my final answer. Now, my slope is going to be 3, or 3 over 1. And again, it's going to make sense here in a few seconds. And my y-intercept is 7. My slope isn't 3x. It's the number that's with the x. Okay, so please be careful of that. Remember that for in the not too distant future. So again, plug your slope, plug your point into the point slope form. Unfortunately, this will not be given to you on your SOL either. Good news is I haven't seen this type of question on the SOL in a little while. Okay, but I still want you to know how to do it, know how to see it, for just in case something crazy might happen. So, I told you, I gave you a clue, I put stars by it. It's bolded this time. Here's your practice problem, okay? Your practice problems are a little bit more difficult than the ones that I do, but that's because you need to do some more difficult problems than the ones I do sometimes. So make sure you guys take a look at this guy and see what happens, and we'll definitely talk about it when I see you in class. Now, here's the next big things that we're going to talk about right now, are the slopes of parallel lines. Okay? If two lines are parallel, which is exactly what these mean, that symbol, then their slopes must be equal. If two lines have equal slopes, then they are parallel. Also, any two vertical lines are parallel, and any two horizontal lines are parallel to each other, which should just make sense. Now remember, that word parallel means that they'll continue forever in both directions and never ever touch. So that's exactly what we're looking for here. Now the big thing you need to remember is that the slopes of parallel lines are equal. So that's what it's asking us now, is it gives us L1, it gives us L2, and it asks us if the two lines are parallel. If it gives you points and it starts talking about parallel or perpendicular, the clue is to calculate the slope. So the first thing I have to do is I have to calculate the slope between 1, 5 and -2, -4. And it's just like what we did on the last video. I have an x and a y, I have an x and a y. So the slope is y minus y over x minus x. Okay? So the slope says 5 minus a -4. And again, I do need both negative signs. 5, this is a negative, minus 4. 1 minus a -2. Okay, so I do need both negative signs again because these points are negative. So, 5 minus a -4 is the same as saying 5 plus 4, which is 9. 3 minus a -2 is the same as saying 3 plus 2, which is 3. I cannot stop here. I need to simplify my fraction. Now some of you want to say that it's a plain old 3, and you're absolutely correct. But I like to say 3 over 1. And again, you will see why. You will see why. Okay, I promise you. I hate to keep saying that and not do it, but you will see why. Okay, so my original slope, or my slope of L1, is 3 over 1. Now I need to calculate the slope of L2. I have to do it twice. So 3, 3, and 1, -4. So slope again is y minus y over x minus x. Once again, I'm going to go ahead and switch it up and let this be x and y. This is x and y, but this time I'm going to start off with this -4. If I use -4 as my first y, 1 has to be my first x. And I'm doing that on purpose. Y minus y. Minus 3. Now notice, I do not have a double negative sign every single time. I only have a double negative if the point that I'm using twice, or the point that I'm using second, has negative coordinates. This guy has positive coordinates, so I can leave that alone. So y minus y, so -4 minus 3, over x minus x, 1 minus 3. Okay? So, -4 minus 3 gives me a -7. 1 minus 3 gives me a -2. Now, when I do my math and I need to reduce this, it tells me that the slope is positive 7 over 2, because if both numbers have a negative sign, I could get rid of the negatives and make the whole thing positive. Now, what we need to look at is these slopes. Remember that we said earlier that the slopes of parallel lines must be equal. They must be equal. So, are these two numbers the exact same thing? Is 3 over 1 exactly the same thing as 7 over 2? You better be telling me no. Okay, you better be saying no. So, because they're not equal, then I can say that no, line 1 is not parallel to line 2. Okay, so they will definitely not be parallel, but that's how I proved it. Okay, you need to use the slope to prove it. If the slopes were equal, if this guy was 3 over 1 and this guy was 3 over 1, then we'd be good, we'd be parallel. If this guy were 7 over 2 and this guy were 7 over 2, we'd be good, they'd be congruent, they'd be parallel. But because they're different numbers, they're not parallel to each other. Alright, I'll try to pick up the pace a little bit. This is your practice problem, so take a look at that and see what you can figure out. Slopes of parallel lines, so this is another example for me. Okay, so I'm given y equals negative 1/2 x plus 5. All that really matters right now is the slope. So the slope of this line is negative 1/2. So that's what I need to remember. Remember, the slopes of parallel lines have to be equal. They have to be congruent. They have to be the same. So I have to find the slope of this line. Okay, so 2x plus 4y equals 9. Remember, I told you before that you're going to see problems like this one, so that's why I wanted to talk about it. We want to get the y by itself. I can't do anything about this problem until the y is all by itself. So let me take a 2x off of both sides. That goes away. I get that 4y equals negative 2x plus 9. Okay, again, remember, we're not going to combine that negative 2x and that 9 because they are not like terms. Okay, they have to stay separated. One has an x, one does not. Third secret phrase, kryptonite. Kryptonite. Now, I need to get the y all by itself, and the way we're going to do that is we're going to divide every single thing by 4. Okay? That goes away. Now I'm left with a plain old y. I get negative 2 over 4x equals 9 over 4. You can leave that alone. I'm sorry, plus 9 over 4. Now I can leave that alone, but I need to reduce this fraction. You must reduce your fractions for slope, and this is why. When you first learned fractions, probably back in the 2nd or 3rd grade, or however old you may have been when you first did it, your math teachers back then probably said, you have to reduce your fractions, you have to reduce your fractions. But I guarantee you, they didn't know why. This is why. Because I need to match up my slopes. And if you tell me the slope is negative 2 over 4, you might not see that they are congruent. But what's the slope of this line now? The slope of my second line is negative 1/2. Are those two slopes the same? Are they equal? Are they congruent? Yes, they are. So then I know for a fact that yes, line L, or line 1, is parallel to line 2. And I've proved that now because I have congruent slopes. My slopes are equal, they're the exact same thing. If you can compare negative 2 over 4 to negative 1/2, you might not see that they equal the same thing. So that's why your slopes must always be reduced. Your fractions must always be in lowest terms. Okay? Now, here's another practice problem for you. So use the other one that I just did to help you out. Remember when I showed you about how to convert from standard form to y equals mx plus b? You might have thought, oh, we're never going to need that. Yeah, you are. So make sure you know that. Rewind, pause, take a look at it, put a star by the problem, and we'll talk about it next class. But make a good effort at this one. Example 6 now wants me to write an equation of a line parallel to y equals negative x plus 4 that contains the point negative 2 comma 5. So we want parallel, so we have to remember, how are the slopes of parallel lines related? Well, the slope of this line is negative 1 because there's a plain old negative sign. Remember, we say that there's an imaginary 1 there. So the slope of this line is negative 1. The slopes of parallel lines are equal, so the slope of my new line is also negative 1. I have a slope, I have a point. What do you think I'm going to use? Point slope. So y minus y1 equals the slope times x minus x1. Remember, the plain old y and the plain old x always stay the same. And now I can just plug my numbers in. Y minus y1, which is 5, equals the slope, which is negative 1, times x minus x1, which is a negative 2. Again, I need the double negative. Minus for the formula, negative 2 for the point. So let's clean this up a little bit, and I get the y minus 5 equals negative 1 times x plus 2, because minus and negative 2 is the same as saying plus 2. Let's get rid of the parentheses by distributing the negative 1. So y minus 5 equals negative x plus, minus 2. You know what I'm going to write as this, plus a negative 2, because that's what some of you guys are going to want to say. So you're going to want to multiply and get -1, and you can put -1x here if you want to, that's fine, plus a -2. Now just remember that that plus a -2 has to be rewritten as -2. So those two negatives, or that positive and that negative sign, come together to form just one negative sign. Okay? Now to get the y by itself, I want to add my 5 to both sides. And I get the y equals -x. -2 plus 5 gives me a +3. So that's my answer for this question. Now the big thing that you need to be on the lookout for are the slopes. The slope of this guy is -1. The slope of this guy is -1. And because they have different y-intercepts, I know that they are parallel. So that's what you need to be on the lookout for. All right, slopes of perpendicular lines, okay? Any two non-vertical lines are perpendicular if then the product of their slopes is -1. If two slopes of lines have a product of -1, the lines are perpendicular. Any horizontal and vertical lines are perpendicular to each other. Now this is what you need to remember. That's what they want us to tell you. That's what you have to remember for a certain question every now and again. But to make sure you remember, negative reciprocals. Okay, that's what you need to remember about slopes of perpendicular lines. Okay? Product means they multiply to equal -1, but that means you're going to have to multiply fractions. And I know you don't want to multiply fractions. I mean, I have no problem with it, but you guys probably hate it. It's probably like going to be torture for you. So let's talk about this and see what happens. This is almost exactly the same as the very first problem that we did for the slopes of parallel lines. So the first thing I need to do is calculate my slope. 0, 2, -3, -2. So label my points. I have an x and a y. I have an x and a y. Okay? Slope formula is y minus y over x minus x. So y minus y, so 2 minus a -2, y minus y, over x minus x, 0 minus a -3. That's an x, that's an x. Negative signs stay the same. This is a -3 in the point, that's a -2 in the point. So please remember that. 2 minus a -2 is the same as saying 2 plus 2, which is 4. 0 minus a -3 is the same as saying 0 plus 3, which is just 3. So that's the slope of my original line. Now I need to calculate the slope of line 2. -2, 3, 6, -3. I have an x and a y, I have an x and a y. Okay? So the slope says y minus y, so 3 minus a -3, 3 minus a -3, x minus x. -2 for the first x, minus for the formula, and then 6 for the second. Okay? Let me go ahead and move this down a little bit. And just put my formula here. So slope equals y minus y over x minus x. Sorry, I know you can't do that on your paper. You have to erase, but that's how I want to do it. Okay? 3 minus a -3 is the same as saying 3 plus 3, which is 6. -2 minus 6, if you borrow $2 from me and then you borrow 6 more, then that means you owe me 8. Fourth secret phrase, fill the peddler. Fill the peddler. Now look at this number. Can I reduce it? Yes. You have to be able to see that. Otherwise, put it in your calculator because you must reduce your fractions. Now, I can divide both numbers by 2. So 6 divided by 2 is 3. 8 divided by 2 is -4. Now we need to compare those two numbers. Okay? Now some of you guys might want to be saying, Mr. E, those aren't parallel. Those aren't equal. You're right. I'm not trying to see if they're parallel. I'm trying to see if they're perpendicular. And this is where this clue of negative reciprocals comes into play. Negative means opposite signs. Okay? Are those opposite signs? One's negative, one's positive. That's true. If you remember from Algebra 1 last year, reciprocal means flip. So that's what we're looking for negative reciprocals. We're looking for opposite signs and flips. So if I flip 4 over 3 over, am I going to get 3 over 4? Yes. So they're flips of each other and they're different signs. So yes, I know that L1 is perpendicular to L2. If it's any other situation, they can't be perpendicular. If they're congruent, they'd be parallel, which means they won't be perpendicular. If they're any other match, they won't be perpendicular.